Hey everybody! Thanks again for coming and seeing another show of DynamoDB Office Hours. Today we got a special guest with us, Jeremy Daly. He's one of a serverless developer advocates out there that's been in the community for quite a while. He's been a very strong fan of single table design, which has made me a fan of his. If folks are familiar, Jeremy's the author of the DynamoDB Toolbox, and also, interestingly enough, produced one of the more interesting pieces of content that I've seen around in the serverless ecosystem, which was a serverless musical, which I would definitely recommend everybody, especially Hamilton fans, to go take a look at. It talks a lot about serverless technologies, architectures, and whatnot in a very interesting and creative way. But anyway, so today's show is all about Jeremy. We're going to talk a little bit about what Jeremy's doing these days. Welcome, Jeremy. Glad to have you on the show. Thanks a lot for taking the time and joining us today.
Oh yeah, I'm excited to be here, Rick. Thanks for the invitation.
Awesome. So, let's talk a little bit about what you're doing these days. I know you did the DynamoDB Toolbox, which a lot of people are familiar with. Was one of your. That's how we actually got introduced. I think actually a little bit before you
Right.
released that. We
Right.
talked a lot about serverless or more single table design, of course. But DynamoDB being the backbone of serverless is where you engaged. But let's talk a little bit about what you're doing these days.
Yeah, so it's been busy the last 9 months or so. I actually joined Serverless Inc., makers of the Serverless framework, as the GM of Serverless Cloud.
Nice.
And essentially what Serverless Cloud is, it's a new division of what Serverless Inc. is doing. If you're familiar with Serverless Inc., they have the Serverless framework, allows you to very easily launch serverless applications and do all that wiring behind the scenes, which again is one of the things about serverless that gets more and more complex.
Right.
A lot of wiring behind the scenes, a lot of knobs to tweak, even though you're not managing the infrastructure. You still have to really understand the infrastructure and what the impacts are, especially on things like failures and like scaling and some of these other things. So, but anyway, serverless framework makes it very easy for you. It's similar to like SAM and some of these other, other frameworks that do that. Serverless has been out there for quite some time. So, serverless is great. This framework is great. If you're using the framework, keep using the framework because it's amazing. But what we tried to do with Serverless Cloud is we said, okay, so all these things that are happening with serverless now, and all these new features that are being added, and everything from the best practices from the well-architected framework and the serverless lens and all these things, all these good recommendations that come down, it's very, very hard for your average developer who, maybe is dabbling in cloud a little bit, or doesn't, do anything with cloud, or maybe is, finally evolved to containers and some of these things, trying to look at all of these, this boilerplate and everything that has to be implemented and all these crazy things that have to be done in order to make it easy to launch a serverless application. And the hello world, super easy, right? A lot of blog posts out there,
Sure.
like just, no problem, hello world.
Right.
And then as soon as you want to do something interesting with it, you've got, are you connecting to DynamoDB? Well, right there, that's a masterclass in and of itself in terms of how to use DynamoDB.
As we know,
right?
Yeah.
And then you've got, what if you want to connect to a relational database, serverless Aurora, or just, Aurora in general, or RDS or whatever. Now there's a whole bunch of things you have to think about. And of course, we got RDS proxy now, and there's other ways that you can mitigate some of those issues, but there are just things to think about. And so as soon as you start going down that path of building out a serverless application, what I've seen with so many companies and so many developers is they just hit this wall.
Right.
They're like, oh, wait, I can't do this. Or if I want to do this, now I got to go learn a whole new service. Like I've got to now implement queues, or I've got to, well, what's this event bridge thing? And wait a minute, how do I do throttling downstream services? And so there's a lot to think about there. So the goal with Serverless Cloud was to say, all right, we can't be everything to everyone. We never expect it to be. But what if we could provide a platform right now that's backed by AWS, that can take advantage of all these best practices, bake in as many of these, and I hate to use the word, and of course I can't find the right word for it, but I guess this idea of being, opinionated. Like it is a bit opinionated in the sense of how we implement some of the best practices and how we implement some of these things, but it is very, very open and free, and you can do a lot of different things in this platform. It's still early. We're still in private beta. Go to serverless.com. You can sign up for the, for the beta for this, but But the idea here is to say, what can we do to abstract away as much of that boilerplate as possible and just get you right into developing serverless applications?
That sounds great. I mean, that sounds really great. Now, and we're going to get into some demos, but let's talk a little bit about this. I mean, our community here is a lot more focused on DynamoDB, single table design. We've got a lot of folks, obviously, who touch serverless and technologies and everything also, because DynamoDB, again, the backbone of serverless, really. I know it's funny when you mention RDS and Aurora and all this, and it's like, yeah, we've got Aurora serverless, but is it really serverless? Don't know. Maybe you don't really know what server it's running on, but I mean, I shouldn't say I'm not as deep in those technologies as I might as one might expect. But the reality is DynamoDB is really the backbone of serverless database technology. It is the crown jewel, and so single table design and whatnot is part of this whole thing, right? It's kind of embedded in the serverless data aspect of this serverless cloud. Let's talk a little bit about that. What is this like an extension of DynamoDB Toolbox? Is this what is the nature of serverless data?
Really good question. And actually, I mean, and the other thing to just to go back to RDS for 1 second, I mean, Serverless Aurora V2, which was I think previewed at reInvent last year, is actually really interesting. It's a cool advancement on top of what Serverless Aurora was. Right. Whether it's serverless or not, we don't need to have that debate, but it is very interesting. And so, but anyways, I think that if I take a quick step back just to explain sort of my thinking behind this and my philosophy, I guess, is as soon as I saw you do single table designs, it completely changed the way. I mean, honestly, inspiration, Rick. Because before I saw that, I was like, how do you use this, and what would you use a GSI for, and like, why wouldn't I just create separate tables like I would in any relational database system, and then I'll join them together, but I can't use join, so I guess I can do it in the application or whatever. So it got messy doing. Doing those multiple tables. So anyway, single table design is something I embrace, and once I got it, it was like I don't know why you would do this.
Switch, right?
It's like a light switch. So
I love it.
Yeah, right. So that evolution led me obviously to building DynamoDB Toolbox, and we can talk a bit more about that. But this is my whole sort of serverless career, and I've been doing this. I've been building applications for the web since 1997, so I've been doing this for a while. But obviously, serverless is about 6 years old at this point, and some of these other services. DynamoDB, I think, is a little bit older than that, but basically the idea of what I've been trying to do with a lot of the open source projects I've written is like trying to make serverless easier. And I've got my Lambda API, which was meant to be like a lightweight API router on top of Lambda functions to make it super easy to do that. DynamoDB Toolbox was all around this idea of simplifying the interface into Dynamo and allowing you to create entities. And then I even did a serverless MySQL, which was meant to solve the issue with the no connection pool issue that you get with Lambda functions, which RDS Proxy does a much better job of doing now. Although there's still quite a few people that use serverless MySQL.
Sure.
But one of the things that I realized very quickly with serverless and when building serverless applications was you have so many choices when it comes to data when you're building applications. Not so many choices when it comes to serverless data, though, right? So you could use DocumentDB, you can use key spaces, you can use obviously Mongo and those other things. You can use SQL Server, you could use whatever you wanted to. But data was always more like an afterthought, and I think there were a lot of people who would build a serverless application. They weren't really sure what to do with what to choose. I would say if you're building an OTL, an online transaction, I can't even say the word right, but anyways, OLTP application, then absolutely use DynamoDB. Right. But what we did with serverless data, and this is sort of how I came to this philosophy, was I feel like data in any application has got to be a first-class citizen. And in many cases, I feel like it's sort of an afterthought, right? And whether you're using an ORM or you're writing some sort of database layer or data access layer, it always ends up as sort of this thing that is not like you have to make a lot of choices. You have to think through, well, if I use this, what happens there? And then again, with serverless,
it's almost like, I think, like with the ORM frameworks, right? Other than Toolbox, because Toolbox kind of embraced the idea of the single table design, but ORM frameworks try and like force you into a normalized view of the world, right? And
correct.
again, it does not fit in NoSQL. It just does not,
Totally
right?
agree.
So I mean, you hit a lot of topics there, right? How do I take DynamoDB as a database and use this thing at all, right? How do I apply that to serverless is a totally different story. But understanding how to use the database is the foundation of everything, right? So
absolutely.
if you've got a data layer that's kind of that these constructs are baked in, right? You're already ahead of the game, right? So even though you might give someone something like Toolbox, you know what? I can use DynamoDB Toolbox very badly.
Oh,
right?
absolutely.
There's nothing about Toolbox prevents me from doing all those bad things you just mentioned, right? Creating different tables for everything. I mean, I could use it in really terrible ways, right? So if I assume that serverless data is an attempt to kind of not necessarily enforce people or force people down a path, but guide them down the correct path, right?
And actually, the idea behind serverless data was to be, to basically say, look, here is a data option that's built in, right? It scales, basically unlimited scale because it's backed by DynamoDB. We give you a very simple interface into it, so you don't have to think about some of the more complex things like GSIs and some of the other things. Now, again, with that, there's some limitations, but at the same time, we felt like this would be a good sort of on-ramp for a lot of people, and you can do a lot with it. I mean, our goal is to make this so that you can build a lot of applications with this.
Right.
But this is something sort of an analogy I've been using is this thing has a Porsche's engine, right? I mean, it's using DynamoDB behind the scenes. It just doesn't give you all the interfaces into it. So it limits the interface a little bit, but we think that's a good thing because, I mean, you can be overwhelmed with what you can do with DynamoDB, especially when you start talking about single table design. So that was the philosophy we took. So, I'm happy to go down, there's multiple philosophies here, right? Obviously there's build it directly on DynamoDB and just implement your own APIs. There's the DynamoDB Toolbox philosophy, which is more entity-based, and then we've got the serverless data philosophy, which was trying to find a balance between the two. But yeah, I mean, I can show you some stuff. I'm going to keep talking. It's up to you.
Let's take a look. Absolutely, bring it.
All right.
Let's get into it. And we can dissect what's going on here. Absolutely.
Sounds good. Yeah. All right. Well, so I've got a little demo set up here. So first of all, this is just, if I show this here, this is just a standard serverless cloud project. And again, what's cool about serverless cloud is that your data is just accessible through it. So you don't have to worry about connection strings or any of that stuff. All the permissions are handled for you. So it's kind of a pretty cool implementation of how that works. I'm not going to go through all of this here, but essentially this is just, it looks very much so like an Express app, API.get, API.post, those sort of things. And when you are once you install Serverless Cloud package, essentially you just run cloud, and this goes ahead and connects to this remote instance that you get to work on directly. So this is just the sample app that we have here, and this is a simple to-do app, but like, for example, you see, a couple of different to-dos here. I can go ahead and check these off. I can delete them. I can show incomplete. I can show complete. This is all powered by serverless data, by the way. We'll get into a little bit about how this works. But another really cool feature of this is that if I'm deleting all this data here, I have a really great command that I can just run import. And that'll actually take data from this data.json, which is just the seed file that sort of stores the information that I want in there. And that actually goes ahead and just repopulates it back into the database for me. So it gives me a really cool workflow where I can create multiple files to change the state of my application as I'm testing it and building against it.
So this is actually really cool because it gets into a best practice that I like to talk a lot about with serverless, is that you want a deployment pipeline. You want a repeatable process to deploy and test your application. As a matter of fact, just because you're serverless doesn't mean that your development best practices go out the window, right? I mean, in Amazon, people get overwhelmed very quickly with AWS because you get into the serverless and you have all these options and Lambda. Heck, I can write a function and deploy it right there from the console. Should I? Just because you can doesn't mean you should, right? And this is an attempt to be able to give people a framework to operate within that gives them a lot of flexibility, but then also repeatability, right? Because
Right, absolutely.
everything is templatized. Everything becomes, your application stack becomes deployable, right? And deployable in any environment, right? And that's what's cool about this. This is not just, hey, here's a bunch of tooling to go deploy a bunch of functions. It's here's a framework within which to define that stack, right?
Right. Yeah. And I mean, and what's cool about the way that we're doing the sort of infrastructure as code is, we said, look, infrastructure as code is great, but it separates a lot of concerns where with serverless, infrastructure as code actually, in our opinion, doesn't make a ton of sense. And part of the reason why it doesn't make a ton of sense is because you're essentially defining a function and some route to a function, and then you have to go and actually define the code for that function. And that's all sort of synced together. It's not like you're deploying some artifact. Like, that's all connected together. So we said, well, what if you didn't need infrastructure as code? What if you just use infrastructure from code? So that's essentially what this is that these little helpers here, API data schedule, there's a couple of other ones, params is a new one that we've added. Those are ways that when you say API.get, whether this is deployed with API gateway with a Lambda function backing it, or it's deployed using a socket and a Fargate task, or it's deployed some other way. I mean, it could be deployed on EKS with Kubernetes. The point is that it really doesn't matter to you how the infrastructure gets deployed. It's just that by you giving it these hints, API.get, and there's another thing down here, schedule.every 60 minutes, for example. These are just hints that tell our system to generate the correct infrastructure for you. So they're very repeatable, right? Like, these are repeatable and deterministic deploys, so you don't have to worry about that. And actually, one of the things I didn't show here, and I probably should, is that when you actually deploy these things here, if I go into my DynamoDB here, it'll actually show me the API routes that I've generated that get read from this. So it's infrastructure from code. We don't know if it's a new thing. I mean, we like the idea of it because there's no YAML files, which I think can get overwhelming. But
that's what I was just going to ask about, right? So some people are going to look at this and they're going to say, well, I could do this with CloudFormation, right? Potentially, right?
Potentially,
so,
right?
Why? What? Where's the benefit from this over sort of the CloudFormation or CDK type of implementation? What's the where does this fit in that ecosystem? Do those tools ride within this? I mean, how does someone who's kind of ramping in those tools, what do they do with looking at these tools?
Right. Yeah, right. Well, so I mean, as it is right now, this is, in order for this to work, it has to be deployed to the serverless cloud. So because it is a runtime essentially that we read in and process. We there's all kinds of ideas about, open sourcing parts of it and so forth, and being able to maybe do white labeling solutions and things like that, but nothing that we're really worried about right now. What we want to do is focus on the best possible serverless developer experience, and forget about serverless, just developer experience.
And I think that's the answer, right? It's like, look, okay, sure, Wild Wild West over there. At least there's some guardrails over here, right? Right. So guardrails over here will prevent you from doing crazy things that will break you.
Exactly.
And so that's what serverless cloud is. It's the aggregation of the experience and knowledge of some of the best practitioners in the space who've come together and said, here's how we believe things should be done. And, within this, if you operate within this framework, you're going to have a good experience, right? And that's really what it comes down to. If you go out on your own, you may or may not have a good experience, right? It all depends on, what you create. And so I really think that this is really the type of framework that needs to exist for serverless to start becoming mainstream, right? People need to, have this type of tooling. So I think it's really exciting what we're seeing here. Absolutely.
Yeah, and to the point that I made earlier about that confusion or the complexity around wiring things together, this idea of saying, you have, like, if you use CloudFormation directly, you've got to write the API gateway, you've got to write the routes for the API gateway, you've got to write the Lambda function, you've got to write where it's pulling the Lambda function code from. Like, you got to do all these things. Like, we're just bypassing all of that. Now, CDK, SAM, serverless framework, a lot of those things automate a lot of that for you as well. But we're like, how can we make it even easier? Just, I'm an Express developer. Great, write an Express API.post, and magically all the infrastructure you need is created. So we're trying to remove the idea of primitives, and how far we can go with that, we don't know. But rather than thinking about data as being DynamoDB and a table, we're thinking of data as an abstract concept that's just data's there. Like, you need data, here you go. Same thing with API routes, schedules, things like that. So really trying to get rid of that primitive idea. So
I mean, I would say that you're providing a higher level function than CDK. SAM provides you like a starting point, right? Here's a basic template. Now you build, right? CDK gives you tools to build with, right? But you guys are saying we might even use CDK. We might even, we probably wouldn't use SAM, right, in serverless cloud, but some of the patterns that you have implemented underneath these APIs, they conform to SAM template patterns. They're just extended versions, right? Like you said, when you deploy API gateway, you got to define all these things, right? And why does a user have to do that over and over and over and over again, right? Let's give them a higher level construct. Says deploy an API gateway. We understand in the environment you're in, it has to have this. So let's go ahead and set all that up for you and make sure that it's secure, make sure that all the permissions exist, the roles exist, everything that needs to be defined to support that API gateway exists, right? What are all the dependencies? And it's kind of like CDK is great, SAM's great, but they leave all that up to you, right?
Right. And you mentioned IAM, or you mentioned roles and permissions. I mean, that is something that, again, is another master class, and probably a PhD level thing that you need to do in some cases to know that. So that's one of the other things. Like, we're in the process of building our eventing system, where it allows you to send events, either intra-service or inter-service, so you could send them across services. And we're actually using a really interesting isolation model here. So every single instance, which again, I'm not going to go into too much detail of what that means, but basically every version of your app that you're running, that runs in its own separate AWS account, completely locked, no outside access and so forth. So you've got this really good isolation model, but you might have services that need to communicate across those accounts. So Event Bridge cross-account communication, and pulling DynamoDB streams and sending events across different accounts. That's all really complex stuff to set up. Serverless Cloud is actually going to handle all of that wiring for you, and it's going to be as easy as saying like events.on data : updated, right? And that'll just automatically know.
Well, in order to be able to do that, I have to have all this configuration. I have to have all this set up. I have to have these queues. I have to, and again, it's not like you can't do this stuff yourself. Sure, you can, but this gives you, higher level constructs to manage the deployment of all that stuff. As a developer, we talk a lot about as AWS cloud developers, and advocates, we talk a lot about undifferentiated heavy lifting, right? And it's so funny when I'm hearing you talk here, what I'm hearing is undifferentiated heavy lifting in cloud configuration, right?
Exactly.
Which is, it's like this stuff is becoming to the point, it's getting to the point where, we need to automate the cloud to be able to make it as efficient, to drive the next level of efficiency, right? It's not that, hey, think about what it was like back in the day for a developer to deploy something like an API gateway.
Right.
Okay.
Right.
Let's call up the hardware vendor and order the hardware. 3 months later, we can talk to the IT vendor and deploy it to the data center. Let's get the racks, let's get the power, let's get the cooling. Hey, we don't have to do all that. That's great. But now it's like we're going to the next level with this stuff. We're like, hey, you know what? It's really a pain in the ass to do this over and over again. Let's automate all of it, right? And just make developers focus on the value, which is the intellectual property that they build with the company, not the ability to deploy a Kubernetes cluster or whatever it is, right? I mean, this is the crazy thing I hear about talking about people deploying this infrastructure, even databases, right? Why do I want to deploy a dedicated fixed instance database to do anything, right?
That's
I mean,
crazy.
If I'm writing code, it's probably an OLTP app, right? 90% of the apps we write are OLTP apps. If it's not OLTP, then it's probably not automatable, which means that it's not, I can't really code it. I might have some supporting methods to call some query, but whatever it comes down to, someone's got to write a query, right? An ad hoc query. If I'm not writing ad hoc queries, it's an OLTP app, even if it's operational analytics. Let's throw that stuff in a NoSQL database. And what's the best NoSQL database in the world? Hey, it's DynamoDB, right? I mean, heck, there's other cloud providers have their versions or their variants of that distributed backplane service, right? You got Cloud Firestore, you've got Cosmos DB, and those are good, like, I guess, followers, I'd say, but they honestly, they don't have the robust feature set and API. They might differentiate here and there, but they don't have 5 nines availability out of the box at the push of a button, right? I mean, that's just not, they won't even offer it, right? So that tells you something about the level of service. Anyways, I digress. I can talk about DynamoDB all day.
I'm sure you could. I mean, I could too. I mean, and that's why we chose DynamoDB to back this thing, just because there's a lot of flexibility in there, and it did a lot. I mean, the design philosophy was sort of there. I want to mention one other thing though, because you said you could do this in CDK, and you could absolutely string together a bunch of constructs and build some really good repeatable deployment and things like that. But one of the other things that we tried to do here was also add in workflow, right? So when you're in this sort of, and again, this is what we call a personal instance. So this is like you're running local host and you're running this just for you. So any changes you make here as you're in this interactive mode, they actually get synced up automatically. We'll see some more of that when we start playing around with the data piece. But like, for example, if I start checking things off or deleting things or whatever on the code here, I'm updating my personal instance. But if I want to share this with somebody else and I want to continue to sort of muck around with my code, I have a really cool command. I can just type share. And this will actually generate another copy of this instance, including the data. So it'll take the instance, it'll take the data, it'll put it all together, and it will generate a new URL for me. And then if I open this URL, now I have a fully functional app that is using the updated version of the data, which I can go ahead and play around with on this side. I can, delete things here or whatever, but that actually has no effect. Oops, back to this one. This has no effect on the local version of it that I'm running, my own personal instance. And I can share as many times as I want to. I can go ahead and actually deploy this to what we call stages, like prod or staging or like a dev instance for a larger team to test. So I got a lot of control over this, and that's by having data as a first-class citizen and as part of each instance and baked into the instance, that allows us to do these really cool things like share snapshots of the data as part of these, as part of this sort of collaboration workflow.
Cool.
Yeah, so why don't I I don't know if there's any questions popping up here or anything that we want to address, but I'm happy to sort of jump in and start showing some of what's possible with the interface.
Yeah, let's go ahead and keep diving in here. We've had some questions. We've got Giselle's online answering most of them. Things about possibility to use Python, Java, whatnot, more or less generic.
Right.
We did have somebody come up and say this little comment. I'm pretty sure MongoDB is the best NoSQL. I would definitely argue against that, but that's a personal preference. Honestly, nothing has the kind of scalability, right? The elasticity, the ability to support, and nothing in the world has scaled. No NoSQL database in the world has scaled to the level of DynamoDB, right? We have, I can't remember what they said as far as the ungodly transactions per second we did on Prime Day last. It was like over 80 million. I can't remember what it was per second across, and that's just 8 of Amazon tables. I mean, the backplane is peaking constantly in the hundreds of millions of transactions per second. There's nothing else in the world that's been deployed like this. We support millions of customers, millions of workloads. So we can get into the ins and outs of the APIs. Like I said, you differentiate here and there, but bottom line, scalability, performance, elasticity, nothing beats Dynamo.
Absolutely.
Anyways, let's go on to showing us a little bit more about your application here and your service.
So let's get into data a little bit. So again, what I did here in this sample app is I just created a get route for data. Again, this is if anybody who's ever used Express, and this is Node only right now. We're focusing on Node. Maybe down the road we'll add Python and some of these other things, but essentially right now it's Node. So very familiar to any Express developer. But what I'm doing here is I'm just actually using data.set. So we get this little helper function up here. So data.set, and I'm just setting test as a key and some value as a value. And then I'm going to go ahead and get that back and then just share the result here. So I actually have this /data right there. And so essentially when this runs, what it does is it grabs or it sets some value and it retrieves the test here. So this is super simple, key value store. If that's all I need, I just want to pull back some value that I'm incrementing or I'm doing something with, I can do that.
Now, what's
But
nice about this, let's think about this for a second, right? What
right.
you just did was you pushed this data back into a DynamoDB table, right? And the system determined what that table schema needs to look like based on the characteristics of the data and the characteristics of the request. I didn't have to configure an SDK call. I didn't have to set up the connection parameters. I didn't have to do any of this stuff.
Right.
It's just get. Okay, we're going to go do
no
this,
IAM parameters. No,
right.
Yeah, right. Nothing. Just it's
all that's been configured
there.
and parameterized at some level when you deploy this app, when you set up this application, and again, it just decreases the amount of code that a developer has to write to do things. And,
right.
And that's the value that you're bringing here, right? So, sorry, I mean, because that's a perfect demonstration.
I love it.
I mean, that's like 15 lines of code that you just knocked out right
exactly.
there.
Exactly.
Data.set here, bam, done. Knocked
right.
it down to 2 lines of code, right?
Right. And then the data.get, the idea is that you just get the key. So in this case, it's test, and we'll get into more complex keys in a minute. But so you just do data.get test, and our philosophy here was, in most cases, you just want the value, right? So if I'm just setting, some value, maybe user email or something like that, whatever it was, I just want to get that value back because I want to use it in my code. But there's a lot of metadata that is behind the scenes for these things, right? So we actually have a couple different ways that you can do this. You can either specify meta true as a second parameter here for your get function, like this. If I spelled that right, did I do that right? Yeah. No, this I tell you, I do like this new GitHub auto coding thing, but sometimes it gets in your way, and that's because I have this here, and so it is yelling at me. So you can just specify.
So it was actually correct.
It was actually correct. Yeah. So you can specify meta true like this, or we have a shortcut because this is such a common thing to do, is just to put true as the second value there. And now when I save this is one of the cool things about Serverless Cloud. This actually goes ahead and syncs this to this local instance that I have that's running in the cloud there, and the speed of this, we are working to improve that, but it is very fast to do that. So now when I refresh this now, I'm actually going to get some metadata back. So I get the key, which tells me it's test. I get the value, and I also get a created and modified date. And this is one of the things I brought over from DynamoDB Toolbox was automatically creating these created and modified dates, and using a really cool, function to make sure that if the created date already exists, you don't overwrite it, but you always are updating the modified date every time it changes.
Yeah,
so it's actually
that's great. That's awesome, because that's a best practice, right? This is
right. You should have it.
Again, absolutely, should always happen. And so again, that's like 5 lines of code right there. Give me the timestamp, current system timestamp in milliseconds. Let me tack it on here. Oh, I got to create an ISO 8601 because I might want this to be string sortable, and then, we've got, again, 2 parameters that need to be updated as part of added to the item, and values need to be stuffed, and, all this work. Right? All this work to handle that metadata that you want to put on every single item you insert in the database. So if I want to put this on every single item I insert in the database, why wouldn't I have a framework that does that?
Yeah, exactly.
And some people might argue, why doesn't DynamoDB provide that as an API option? And I would say, absolutely. Let's get that PFR file and start upvoting it, right? I mean,
that'd be less code in our abstraction.
Less code in your abstraction, right? I mean, but this is, again, so this is what you're trying to do. You're trying to offload this undifferentiated heavy lifting, right? If it's a best practice to tack this onto every item, then why the heck do I want to have to write the code every time I store an item? I want to just save it. Boom. So this is again value add here for a developer's experience. This is why you want to use tooling like this.
Right. And so another thing is we just used a simple value here, but clearly you can take advantage of any, data type that's available in DynamoDB. So if we wanted to do an object here, and we wanted to specify something like test123, and maybe let's do ID is 123, so that's a number, and then name is test123, and then let's say active is true, right? So we've gone ahead and put a number, we put a string, and we put a Boolean there, right? So if we save this now, let this sync up, then when we run this again, this will go ahead and run the set and the get at the same time for us. So this should come back now, and it gives us a Boolean, it gives us a number, and it gives us a string, and has now formatted that value for you. And again, if you wanted just that object structure back, and you want to get rid of the request for the the request for the metadata there. Then as soon as that syncs, you would have the ability to pull that back, and that's just going to give you that object structure like that. So that's very basic. That is the idea of basically saying like, hey, I want to just have a simple key value store that I don't need to think about. I don't need to think about. Now you could do, to do 1, to do 2, to do 3, or you could try to find some way. Maybe you could store a list of them in another object, in another key, so that you knew what the other keys you could access were, or you could do a bunch of really bad practices in order to save collections of data. So one of the things that we did, and this is something we're still experimenting with, but we think it's a it's a good sort of design philosophy, is you can actually create collections, but collections are super easy to create in that all it is just a prefix. So let's say that I wanted to create a user.
Let's talk about what is a collection, because I know what you mean when you say collection, but I think some of our users might understand. What is a collection?
All right, so the idea of a collection is it's essentially a partition, right? So if you know DynamoDB, we're talking about a partition. And the idea behind it is to say, if I have multiple items that I want to be able to bring back in a single query, the only way to do that in DynamoDB or in any NoSQL database is to create them, have them as part of an index, right? Or have them as part of a partition. So in this case, what we do is we say the collection itself is the partition, and that the key that you're using, that's going to be the sort key, right? So that's what we're trying to do. So we're basically allowing you to create partitions, but we're trying to hide that a little bit from you so that maybe it's a little bit more understandable, because I think if you start talking about partitions and sort keys and some of that stuff, it gets a little bit confusing. So let me show you the example here, because I think this will make things, it'll make things a little bit obvious in terms of how this stuff works. So right now what I'm going to do is I'm going to set a key, and I'm going to use user : and then Rick, right? So user is what I'm defining as my collection. Now, in real applications, you would want there to be a lot more cardinality to that, right? You wouldn't just want to use something generic like user, but this might be like user 1, 2, 3, or XYZ users, or something like that. But essentially what I'll do is I will go ahead, and because this is already auto-completing for me, because I already did this before, which is pretty cool about Copilot there, so that's kind of cool. But anyway, so what I'm doing is I'm setting a user Rick with ID 123, your name Rick, and setting your active to be true. So actually what I'm going to do here is I'm going to capitalize your name there because that's just it. I'm going to get rid of the active piece. And then let me do this. I'm going to go ahead and copy this over, and let's make a user for me. If I could spell my own name right. And I'll do 321 and Jeremy. And then because another important figure, still can't spell my name right, another important figure I think in the DynamoDB community is our good mutual friend Alex Debris. So let me put Alex in here, and I will make him user number 456 and update this with Alex. All right, so now I have 3 users that I'm putting into the system. And again, sometimes Copilot does make things. Okay, so I've got 3 users that I'm putting into the system. So under normal circumstances, if I was going to go ahead and return any one of these users, I can just specify the name. So I want user : Rick, right? So I'm going to save this, let this sync. And then I'm going to go ahead and run this query here. And what this should do is it should return just your user. Your user Rick with the values 1, 2, 3 and name Rick. So this is simple. I can do the same thing for user Jeremy, for user Alex, whatever I want to do. I can get an exact match so it works just like the normal key value system. But collections give us superpowers. So if I want to get all the users, I can just do user : star. Now, if I save this and let this sync, what this will do is this will look for any user, or any item, I should say, in this user partition. So now when I go ahead and refresh this, I'm going to get a list of 3 items, which are going to give me Alex, Jeremy, and Rick. And if you notice, if anybody is keen on the way that sort keys work in DynamoDB, you'll notice that these are lexicographically sorted. So Alex comes before Jeremy, which comes before Rick.
And that's because you defined by saying data.set, you've basically defined a partition sort key structure using the colon.
Right.
So,
correct.
Yes. So this is all underneath the covers, this just happens for you. You don't have to create the table. You don't have
Right.
to set the keys. You don't have to, and it's because you're using kind of common assumptions that we make when we create DynamoDB tables in single table design, right? The partition key, the sort key, it doesn't really matter what the names of those attributes are.
Correct.
What matters is the value that's inside them. So, Serverless Cloud says, hey, let's just create a table that has a PK and an SK, right? And now I can be very flexible about how people use it. If they provide me the colon, it tells me I need a sort key. If they don't give me the colon, it's a partition key only, right? So,
correct.
It's just and I don't have to, as a developer, know what kind of table I'm building, what kind of table I need to support my application. And I imagine there's some way to be able to set capacity, set limits on particular access patterns or tables or data collections, so to speak. That can be set at the highest level of the application when I define these things. Right. Yeah. So,
I mean, there's a lot of flexibility we're playing around with now, and one of the things we want to see is really what what users are going to do with this and what they're going to kind of build with it. I mean, and we'll recommend best practices, but we want it to be a little bit flexible now and sort of see what people do. But one of the things I want to kind of just go through is with this get functionality here, and I don't know if anybody noticed this, but when you do anything that uses a collection, that is going to return more than one item. So if it's not if you don't specify the exact key, any of these sort of query operators, if we want to call them that, will return, will return an array. An array of objects. But you can do things like limit. So if I want to put a limit of 2 here, then when I run this, a couple cool things that happen is, one, it limits by 2, but it also gives me this last key. So it tells me what my last key is, which means the next time I want to actually query it, I can do start and I can specify user Jeremy as my last key. And then, thank you, Prettier, for making this easier to read. That once that's actually synced, now what will happen is this will go ahead and run, and this will just load you because you're the next in that pagination. So there's some other pagination stuff we're working on and playing around with some interesting things there. But there's another cool thing you can do here too, is you have the option to just do reverse, and you can just say reverse equals not ter equals true. And if you set reverse equals true here as part of that, then what it will do is it will use the Alexa, it'll sort of in the opposite way, right?
So you get forward index false, right?
Exactly. Just, and again, like this is another sort of thing that I brought over from DynamoDB Toolbox. Like if you say scan index forward false, what does that mean?
Right, exactly. Happens to me all the time. What is forward false and true? I don't know, right? What's
exactly.
Forward, right?
It gets a little bit confusing. So then just a couple of other shortcuts that you then have in here, for example, is if you wanted to say, I want all users, so I got rid of the reverse, so this will sort by Alex first. If you said, I want to get all users that are greater than Alex, so I just put a little greater than thing in there, and I go ahead and save that. And then again, this syncing will be faster. So but when you're developing, we're usually not doing this as quickly.
Not worried so much about it. Yeah.
So this will just pull back anything greater than Alex. And the other thing to think about is if you did something like, let me see all users greater than A. If you're familiar with lexicographical sorting, then you would know that this will also bring back Alex because Alex is greater than A, for example, right? So that's just some. AL is greater than A, right? Yeah. So in this case, you could just do greater than B, or you could even do greater than or equal to B as one way to do it. But so let me do one other thing. The other thing I meant to do is actually comment these out because you obviously don't have to set these every time, right? These are just part of the system. But let me add another user here, and we'll add another user, and this one will be Alexa. All right, and we'll do Alexa here, and we'll do 6, 7, 8, or actually should be 7, 8, 9, right? Okay, so we'll do this, and then we'll get Alexa as another user here. But another cool thing you can do is you could say, well, I want to get any key that starts with Alex, and this uses that begins with capability. So I can do Alex star, and then if I was to search for this, then I should. Whoops, it didn't sync yet. Do it now. Or what did I do here? Am I not? Maybe I didn't sync. Oh, I didn't save that part. Okay, hold on. Didn't save that one. All right, so sync that. And then when I when I run this query now, I'll just get the two names that start with Alex, right? So a little bit of cool functionality there that you can use. And so that gives you, that's the idea of collections, right? That you can go ahead and create these groups of items, and you can pull them back.
And honestly, again, it takes care of some of that housekeeping code that we all have to write, where expression attribute names, expression attribute values, define the expression, all that kind of. It's like, why do I want to do all this, right? I mean, it's just extra stuff, right? So this is a great. Honestly, these have been complaints I've had about the API for some time. You guys are providing an experience, a developer experience, which is more fluid, which is exactly what the system needs, right? And I'm liking a lot of what I'm seeing here. Now let's talk about some of the other kind of things that we always talk about with single table design, things like entities, right? How do I enforce constraints? I mean, because one of the things I loved about DynamoDB Toolbox, of course, was the ability to define entities, to have constraints, to have the ability to create, value templates for attributes and auto-generate your composite keys and all this kind of stuff. So, I mean, is that stuff coming with this as well? Is it there? Is it stuff we're working on?
It's not there yet, but it's also one of those things where it's like, we've talked a lot about entity-based design because we do feel, the whole team, is behind this idea of entities because it's just a much easier way to think about, DynamoDB, right? And
your data in general.
Your data in general, right?
Yeah, exactly.
And even what we do, so for serverless cloud, the back end of it, so we've got, obviously instances and services and users and all these other things that all tie together. That's all running in a single table design, right? And we've got maybe, maybe 5 or 6 GSIs on there that we can sort things in a couple different ways. But that is something, though, in terms of, and maybe we talk about GSIs for a second, because entities is one thing. Like entities, I think is a really great way to sort of enforce, the structure of the data that you're using. I don't think we're there yet with serverless data because, again, we want it to be very flexible and we don't want you to have to do that. Like with DynamoDB Toolbox, you have to create an entity. You have to tell it what fields you can put into the system, right? And we just didn't want to have those constraints, at least not in the beginning. And maybe it'll be one of those things where it'll be an optional thing to create those for you.
And I would also advise, even when you do create those entities, you should have strongly typed entities and loosely typed entities, and things that must have at least this, and maybe even value restraints on this and things like that. I mean, a lot of really cool functionality you can put around these things. I can totally see all those constructs appearing in this serverless data framework. This is honestly, that's the stuff I think it's going to really start to sell this thing to developers. Is when you start to incorporate that type of functionality, that'd be really, really interesting to see that.
Right. Yeah, and I think that's a great point, and that's certainly the road that we probably want to head down, because it does give you a little bit more. It gives you more predictability, and I also think that it's great just to define those and to see what that is, so that it's like event bridge, event schema registry, right? Like you have, it'd be nice to have that so you know what those are. But even with DynamoDB Toolbox, I mean, again, the approach there was to create entities that were highly structured, and that some were required, some weren't. Some fields are required, some aren't required, and there was other little functions that you could automatically update something whenever you saved it, and some other things where you could manipulate data. But one of the biggest things that was kind of left out of DynamoDB Toolbox, and this is not because you can't do it. It's just the idea of actually generating GSIs. So you can specify your GSIs. You can say, hey, when this happens, set this GSI as that. But you did really have to think about, GSIs and how some of that stuff works. Sure. What we tried to do with serverless data, and again, we don't know if this abstraction is right, so we'd love feedback on this. Right. But one of the things we did is we said, what if we got rid of the concept of GSIs, and also embrace this other philosophy? You and I talked about this, I think, 2 years ago when you were on the podcast. We talked about this idea of that evolution of single table design, where there was a lot of reuse of individual attributes as part of other keys. So your GSI 1 might include, the PK and then some other attribute that's a different way to sort it. right?
That or something, right? Yeah, exactly.
Right.
Yeah,
And
yeah.
then I think what we discuss and what I've certainly seen and what has worked really, really well for me, and I encourage everybody to think about single table design this way, is attributes are cheap, especially attributes for
Yes.
very, very small, identifiers, right? So
Right.
the idea of saying I've got a PK and an SK as for my primary index, if you want to create a secondary index, even if 99.9% of the time your partition key for your GSI1 is going to be the exact same as your PK for your index, I still suggest you just create a copy of it. Create a copy of it and create two separate attributes that store the PK and the SK for those extra GSIs. Because that just gives you a lot of flexibility. And of course,
that's it. It's flexibility down the road. I mean, maybe
Right.
right now that those PKs match, but hey, what happens if I come in and I add a new access pattern? Oh shit, now I got to delete that GSI and create a totally new one. I got to table scan and write back a GSI key to all those items. You know what? Those index attributes, those are keys. Those are lookup. Those are like the tabs on your folders in your file cabinet, right?
Absolutely.
Of course, I'm going to have some information that's written on there that I might also have written in the file itself. This is what we want, right? We want to have identifiers to go search for things. So think of them that way. That's what it is, search tag.
Right. Right.
Not data container. Right. As a matter of fact, the search tag needs to be updated when the data container changes, and the data container is the top level attribute inside the item itself. I totally agree with you.
And that's how I always look at it. And one of the things that I love to or that I think is a superpower of creating or of any NoSQL index is the idea of sparse index, right? The ability for you to only populate things in certain cases. I mean that query for showing me all of my, let's just say, I'll just use this as an example. If I was building a DynamoDB table that was storing emails that like an email inbox, my unread emails, for example, can just be a GSI that, that has a flag in there. And that's such an efficient query because I don't have to sort through, 10,000 emails in order to find the ones that are, have some attribute that's flagged as unread. So there's just a lot of powerful things that you can do there. So using that design philosophy, which I think is spot on and is absolutely the way people should go, we tried to figure out a way of how can we give people that, basically enforce that requirement of them to say, I've got to create a separate PK and a separate SK, but make it in a way that we thought was logical and easy to do. So again, we don't know if we hit the mark here, but I created another JSON file here called users. I just copied in what we had for, that we kind of wrote before. But what I did here is we've added in two extra things for each one, except for Alexa here, is this label 1 and label 2. Essentially, that's GSI1 and GSI2. But what this has done is this has allowed you to go ahead and create either, you can create simple keys if you wanted to, or you can create collections again. So you're basically doing the same thing. You're using the power of that GSI, but this is forcing you to basically specify the PK and the SK as being unique. They don't have to be unique, but being different or not occupying the same space as the primary index, right? So so this is where this gets kind of cool. So if I import, I'm going to import users.json here, which is another cool feature. So again, if you're developing your data and you want to change the state of your app and try a bunch of different things, you can just go ahead and create as many JSON files as you want with whatever data structures and things like that, and you just go ahead and run them. It imports them, and now you'll have the updated data. So now when I actually run this here, let me make sure that I have commented out the update to Alexa, which I did. Okay, so if I go back over here and I run this, now I'll get that imported list. Oh, actually, hold on, I'm simplifying here. Well, it doesn't matter. Anyways, I've got the updated stuff. You can see the labels and the labels there, right? So now what I have the ability to do is I can say get by label, right? And again, is it the perfect abstraction? Not sure, but it's what we've gotten where we want to test it out. But so now I can specify the label. So if I say label 1, now I can go ahead and say I want to go ahead and get everything that starts with Twitter or is part of that Twitter that Twitter collection there, right? So I save that, let that sync quickly, and then I'll come over here and run that. And I got an error an exception because I did something wrong. Because I just said label and not label 1. All right, good to know that my error codes are actually giving me information helpful and useful. So that's good. A lot of attention to detail there. So now this comes back and you'll see that, Alexa, Alex, and then in this case, you're sorted before me because it's sorting on H instead of J, right? So that's just another way that it's pulling the data back. You have all the same capabilities here. So if I just wanted to find anything that started with, at Alex, for example, and I save this, then this should go ahead and just pull back those 2 that are there. But I have all that same functionality. And then like another thing that I put in here, so this just shows me those, but label 2 I set as this active inactive, right? So if I wanted to go here and say, okay, on label 2 now, just show me all of my active users. And I could just do active : star like this, save that. And now this will go ahead and pull back only the users that are active. And I gotta wait for it to sync. There we go. So this just pulls back, nope, hold on, now it's synced, there we go. This should just pull back me and you because I've set both of us as active. And then again, speaking of those sparse indexes, Alexa will never even come back because she doesn't even have a label 2 on there, right? So,
right. So inactive users don't have the active stamp. They don't even have the label 2. They don't show up on GSI 2, so to speak. Right. And again, you're kind of abstracting all of it, right? I always talk about, why do you want names on the GSI, right? Names on GSI limits your flexibility. If I say get users by X GSI, then then what happens if I want to support a different pattern on that GSI? I can't do it, right? In this particular case, we have label 1, label 2, but I could put another item on there with a label 1 of a totally different label. It doesn't have to be Twitter. It could be Facebook, or it could be, got totally different access pattern completely, and it'll show up on the same GSI. So you're taking the best practices of DynamoDB single table design here. You're abstracting them from the user, and you're basically saying, why does a user need to define a table name? Why do they need to define the key names? Why do they need to define the GSI attribute names, right? I mean, what they need to do is tell us what the labels are. What they need to do is tell us the dimensions on which they want to query these items. What they need to do is specify what collections they want to create. Those are things that are interesting to the developer, right? All this other stuff underneath, that's not interesting. I just love what you're doing because, again, it's the undifferentiated heavy lifting and you're getting rid of it, right? And that's the best part about all of this. It's like you're carving through all these nice, flexible, functional APIs that AWS gives you to do all this crazy stuff and saying, developers don't need to do all this stuff over and over and over again. They only need to do it once. Okay, how do we need to configure it? Let's set it up for them, right? And if what you're doing is taking the best practices that AWS espouses and essentially automating them, then you've offloaded an enormous amount of work from the user. They don't even have to necessarily, although I don't like this, they don't have to understand what's happening. Right.
I mean, there's still a little bit of an understanding, but I mean, I think what you're saying though, in terms of what you can abstract away from the user without necessarily losing functionality is an important point, because we don't want users to lose a lot of functionality, but we certainly want them to not have to worry about implementing all of that code. And again, our code, we hope, is bulletproof. It's been tested so many times that it's like, we should be able to make sure that the exception that you're getting one out of every 1,000 writes when you write your own code or something like that you might be breaking something. Like, we can test that. It's again, that's the idea of offloading it to somebody else. And like, this is just another thing I wanted to quickly show. So, everyone always says like, well, how do I sort by created date or when they were last active? Well, you add another label, and we give you up to 5 labels right now. Put a date in there, and then sort by the date, right? So you can say greater than this particular date, and you do that. And then we think it's creative. I don't know. I think it's creative. But if you wanted to say, show me everything between let's say I want to say between 2021 August 18th and the 19th, right? I can just use the pipe character here.
Sure.
And the pipe character is just a shortcut for between, where it allows me to put two values in, and then I can go ahead and do, run this, and this will show that both you and I were active between that time. But of course, I can pull back all the inactive users and so forth, and it gives me a lot of flexibility. And then another thing, and this is something where it is more complicated to write an update query against a DynamoDB table than it is to write just a put command.
Sure.
So what we did is we said you don't even have to think about it. You either have set or get, right? Those are the two functions. There's a delete or a remove command as well.
Right.
But so when we do set, we automatically do a merge, right? So we automatically do the upsert. So like if I wanted to update your name here, Rick, and I said, let me update Rick's name, and I want to go ahead and update it to Rick2. Now I'm specifying the ID and I'm specifying the name here, right? And let's say I wanted to add, maybe I'll add another thing. I'll just say, test, and I'll say this is true or whatever. So I can go ahead and add different values, update certain values, and so forth. So I'm going to save this, and then when I rerun this query, this is going to pull you back as part of this, active query here as on label 2. But when I run this query, what this will do is this will update you, right? Give you Rick2, add that attribute of test, but guess what? It didn't change these labels on you, right? It didn't change the created date. It updated the modified date, but it didn't make any of these other changes. So it gives you this sense as a developer, like I'm not performing destructive actions. I can go ahead and modify things without having to worry about specifying everything every single time. And if you really, really, really want to, you have this option of specifying overwrite, and you can
clobber
the item and completely overwrite any aspect of it if you want to do that.
Yeah, that's great. I mean, what you're showing us, Jeremy, is a framework for serverless development that abstracts away a lot of, as we talked about, this the code that's repetitive, the code that's not necessarily the high value stuff, and this is the value add of serverless cloud. We're running up on the top of the hour here. I really appreciate you coming and joining the show. I've had some really nice comments. People love it. They think it's cool. I think this is the best comment here. Abstraction is crazy, but good. Totally understand it. Obviously, this is, and I love what you guys are doing. As a matter of fact, when you guys get closer to launch and you're going to be opening up this up, let's have you back on the show.
Oh,
do
love
a full
to.
demo and show you everything. This is amazing stuff. Again, thanks for the time, and thank you everybody for taking the time to come watch the show, and reach out to Jeremy and I on Twitter if you have any questions, and we'll talk to you later. Thanks a lot.
Awesome. Thanks, everyone.
All right. Bye.